Hello everyone, I hope you are doing well. So in this video, we're going to discuss the first two problems of Codeforces Educational Round 150, which was written for Division 2. So I believe I have not been able to practice much questions these days. That is why I am not able to perform in these contests right now. But I am busy with some work, and as soon as it is done, I'll be back to problem solving, and let's hope then the performance improves. The overall contest I felt was a bit tricky, and even the first two problems were looked straightforward, but you had to think a little bit in order to solve them. And I was very close to solving the third problem. I don't know what went wrong. I was constantly getting wrong answers. So anyways, let us start with the first problem. So the first problem says that there are two players, Alice and Bob, and initially we have been given an integer n, and there is an array consisting of n number of ones, right? So if the value of n is 4, there will be 4 number of ones present in the array, right? So in each step, what a person can do is any one of them, let's say Alice chooses any number of elements that are same. So Alice can choose 2 number of ones, or Alice can choose 3 number of 2s or 2 number of 2s, right? At least they should choose 2 of them. So if they are taking the same number of elements, either they can take 2 number of 1s, or they can take 2 number of 2s, or they can take 3 number of 2s. Since 3 is alone, they cannot take 3 at all, right? So this is the way they can make one move, and when a person cannot make a move, he or she wins. So if Alice cannot make a move further, Alice will win, otherwise Bob will win. We have been given a value of n and we have to tell who will win, Alice or Bob. So let us discuss this particular problem. So basically you will observe, let us start from smaller values of n, let's say for 2, right? So the minimum value of n is 2 itself. So when n is 2, there will be 2 ones like this, and Alice has no other choice but to merge these two, right? So Alice will have to merge and the final result will be 2. So since Bob cannot make a move further, so the winner will be Bob when n is equals to 2. Let us discuss this particular case when n is equals to 3. So 3 will be like this. If Alice takes all of them, this will be 3, right? So one way of doing it like this. The other way is Alice takes 2 of them, so it will be like this, 2 and 1, right? Since again Bob cannot make any move, so Bob will win. Now let us discuss for n is equals to 4. And in this particular case, you will see Alice, if she takes all of them, Bob will be left with 4. So Bob will win. If Alice takes, let's say 3 of them, so 1 and 3 will be remaining. Again Bob wins. So if Alice takes exactly 2 of them, then 2, 1 and 1 will be remaining. And then Bob will take these 2. Then this will become like this. And then Alice will have to take both of them together. And then it will result to 4. And again Bob will win. But something very interesting happens when n becomes 5 or any number greater than 5. Now you will see, let's say and the value of n is 5, so there are 5 number of ones. Alice can exactly take n minus 2 number of ones, right? So if she takes n minus 2 number of ones, there will be exactly 2 number of ones left here, and this value will be 3. Now you will see Bob will have to take these two and they will become 2. And you will always observe, now as soon as like this particular value of n grows even further, so let's say n becomes 6, so this first value will be 4, because if there are 6 number of ones, Alice leaves 2 of them and takes the n minus 2, so n minus 2 will be equals to 4 in this particular case, and Bob will be remaining with these 2 ones, so Bob will add 2 of them, so it will become 4 2. So at the end you will see there will be only 2 distinct integers at the end, one of them will be 2 and one of them will be n minus 2, right? So since Alice cannot make a move further, Alice will always win in this particular case. So whenever the value of n is greater than 4, Alice will win, otherwise Bob will win. So this is the whole solution to this particular problem. You could have just tested for all smaller values n 2, 3 and 4, and then you will observe after 4, in any case Alice can always win, right? So let us have a look at the code now. The code is not very difficult, it's very straightforward. So you see, I take input as n, and if n is greater than 4, Alice will win, otherwise Bob will win, right? Simple. So let us move on to the second problem. So the second problem is they say that there is an array and it is called beautiful if it is possible to remove certain number of elements from the starting and append it to the end of the array. So let me just explain you this part first. So they have given us a definition of beautiful array. So an array is called beautiful. So let's say what is beautiful. So if there are some elements, let's say A1, A2, A3, A4, A5 and A6, right? Let's say I'm able to remove some of them from the starting and append it to the end, such that the array becomes A4, A5, A6, A1, A2, A3. If this particular array is sorted in non-decreasing order, right? If this particular array is sorted in non-decreasing order, then the initial array, this particular array, is called a beautiful array. So this will become beautiful, right? This is our condition. Now let us read the question further. Now they say that we have been given, right, the initial array, and we have also been given an array A which is empty, right? So we have to process q queries, and the queries is nothing like, they're just the elements of the array that we have been given. So for example, this is the array and our ith query will be the ith element of the array, right? So if we can append the integer xi means this particular elements that we have here, to the back of the array such that the array stays beautiful, then we have to append it, otherwise we have to do nothing. Now for each of the elements we have to tell whether we can append it at the back of the array or not. So let me just discuss this particular thing with an example. So if this is the case, these are the elements, right? So they are saying that this is the first element, this is the second element, this is the third element, this is the fourth element, fifth element, and so on, right? For each of those elements I have to test whether I can append this element to the back of my array or not. So my array is initially empty, array A, right? And this array which has been given to us in the input is completely different from the array that we have, right? So we have to test whether I can append this element to the back of my array A or not, right? And the condition that must hold true is that the array in all cases must be beautiful, right? So even after appending that particular element, the array A should be beautiful. And we have to do this for all the values. First we have to push this particular element, then this particular element, then this particular element, and so on. If I can push this element, I have to push it and mark my answer as 1. If I cannot push it, I have to mark my answer as 0, right? So this is our whole question. Now let us discuss what is the property of a beautiful array? How do we actually verify whether an array is beautiful? So you will see, if we want to make the final array non-decreasing, so the elements can only have one dip. So I'll be defining a term dip here. So dip means that if the elements are increasing, then no problem. There can be at most one place where the next element becomes less than the previous element, right? So it's just like you're climbing somewhere and then you make a dip and then you again climb somewhere, right? So there can only be one such instance where v of I is less than v of I minus 1, right? If there is more than one such instance, then the whole array will never be beautiful, right? Why? Because if there are 0 instances, then the array is already non-decreasing, so there is no problem. If there is one such instance, let's say a of 4 was less than a of 3, then I could make a cut here, right? And then this will be increasing, and then this a of 1 should be placed here, a of 2 and then a of 3, this will be increasing, right? The second condition is I can only append this to the end only when a of 1 and a of 6 follow this particular order, that a of 6 is less than equals to a of 1, right? We have to make sure that a of 6, the last element that I have, is less than equals to a of 1, then only I can make this particular cut, right? So we have got certain number of conditions. The first condition is, let me just write it here. So let's say we have some conditions, right? So the first condition is there should be at most one dip, right? The second condition is last element should be less than or equal to first element, right? So these are the two conditions that we have. So let me just move it here. So what do I mean by this particular last element? Let's say in this particular case the dip was at this particular point because 2 is less than 9. So in any case I will always have to move this particular part and append it to the end of my array, right? I can only append this whole particular part when the last element is less than or equals to 3, right? Because 2 is less than or equals to 3, I can append it after 2. But I cannot take 4 now, because if I take 4, then 2 and 4 will be like this, and I cannot append 3, 7, 7, 9 after this, right? Because this will break the chain and this will like make the array non-sorted. So I need to make sure that if I have encountered a dip and I want to make it like such that I want to break the array from here and append this whole part to the end of my array, right? So in that particular case, I need to make sure that this particular last element is less than or equals to the first element, right? So this is what I mean by last element here. This is something I'll have to check. So what is the final approach of solving this question? So let me just show you that with the help of a try run. If I have 3, 7, 7, 9, 2, 4, 6, 3, 4. So obviously the first element can always be appended. So it is 3. Now the next element is greater than or equals to the last element, right? I can append it. 7 is greater than or equals to the last element. I can append it. 9 is greater than or equals to the last element. I can append it. But now 2 is not less than or equals to the last element. That means there will be a dip here, right? So now 2 appends, but I have made sure that there is a dip now here, and I cannot take another dip, right? So there cannot be another element like 1 here. Now all the other elements will have to be greater, otherwise I cannot take them, right? So I have done this. Now what I do, for every other element that I push now, right? So if I try to push 4, I cannot take it, because now the last element, if I take it, the last element will become greater than 3. So I cannot take it. So I will avoid 4. Now I check for 6. Can I take 6? I cannot take 6 because it will be greater than or equals to the first element, right? Now I try to take 3. Can I take 3? Yes, I can take 3. So it will be like this. Can I take 4? I cannot take 4 because it will be greater than or equals to the first element, right? So after I have made a dip, I need 2 conditions to check. That is, there should not be another dip. That means that the next element should not be less than this particular element, and I need to make sure that it is less than or equals to this particular element. So it should lie in the range between 2 and 3. Only if the next element lies between this particular range, I can form my answer, right? So let me just show you the code, and it will be much more clear to you what happens here. So you see, I've created a vector v of size n, and I've taken input in it, and I've created a boolean variable dip. So this will store whether I have taken a dip till now or not, right? So it is initially false, and my string answer is equals to 1. That means I'll always be taking the first element, and I'm storing the last value that I have taken in the last variable. So initially it is v of 0, right? So let us discuss this part first. This part, this is the part where I have already encountered it, but let us not discuss this. Let us discuss this part first. So if v of I becomes less than last, right? That means this element is less than the previous element. That means I have to take a dip now, right? And I can take only if v of I is less than equals to v of 0. If the last element becomes greater than v of 0, then obviously I cannot take it, and hence I have to make sure that it is less than the first element. If it is less than the first element, less than or equals to, I can take a dip. I will add 1 to my answer because I can take this element and I'll update my last as v of I. If I cannot take it, I'll just update my answer as I'll add a 0 to after it. If everything is normal and v of I is greater than or equals to last, then I will add 1 to my answer and last will become v of I, right? So keeping all these cases apart, this is the case when I have already encountered a dip. So in this particular case, I can only take an element only when it is less than or equals to v of 0 and it is greater than or equals to the last element that I have taken, right? If both of the conditions are satisfied, I'll add 1 to my answer and last will become v of I. Otherwise, I'll add 0 to my answer. At the end, I can just print the answer variable. So this was all about the second problem. I hope that you guys were able to understand the solution. If you guys did, then consider dropping a like on this video, and don't forget to share your thoughts in the comments. Any general thing you would like to share or anything about the problem you wanted to share, you can write it down in the comments. As your engagement with this particular video really helps the YouTube algorithm to understand that this video is actually helpful for you, and it will be able to reach more number of people like you who want to keep solving new problems. So share this channel with your friends, and till the next video drops, keep coding, stay safe, bye bye.